In the last couple of parts of the video, we've introduced interquartile range to our vernacular. Now, we talked about how those values are spread out along a scale. And that scale is actually really powerful for demonstrating how data looks. So, the key values for any set of data are as follows. The lowest value, because we'll always need that to be able to find the range. The highest value, for the same reason. The median, and as we've just learnt, the upper and lower quartile. Now, how do we show these in a diagram? Well, first off, someone will give us a scale, a numerical scale, that might start at 0 and go up to 100, and then they'll give us a box and whisker plot diagram. And that looks like the following. Where those 5 values are all marked to show where they are. Clear lines on the ends, lines to demarcate where the upper and lower quartile are, and the same as a line for the median. The box here in the middle to emphasise the middle half, because remember the lower quartile is a quarter in, upper is 3/4. So there's half the data in here. So any outliers would lie in these sections, if there were any. So this is a good diagrammatic way of showing how the data set looks. Now, its best feature isn't just that you can draw them. It's the following. Here's your scale, and here are 2 box plots. Now, imagine these are test scores as a percentage, and the top one is girls and the bottom one is boys. Straight away, you can see what's going on here. The visual representation is really powerful. And one of the key things you'll be doing with box plots is you'll be comparing them. And when you do so, you'll do 2 things. You will compare the median and you'll compare the interquartile range. Now, why would you do those 2? Well, the median is the middle. That allows you to tell which is the higher or the lower set of values. So in this case, your sentence would be, the boys' median, and I'll give it a number at 45%, is higher than the girls at 22%. So the boys scored better on the test. We've talked about the median, we've quoted the numbers, and then we've done this. This is called the context. And this is what the situation is, the test scores. and you'll need that in order to secure yourself the marks. Now, we've described who was scored higher and lower, but we also want to talk about something that we began a discussion on a long time ago. Back in part 2, we looked at two cricketers, one who was consistent and one who wasn't. Now, the interquartile range is a really good way of describing consistency. So, the interquartile range for girls is 10, and for boys is 15. This means the girls' scores were more consistent in the test. So let's have a look at the comment. We've talked about interquartile range. We've talked about and given the two values for comparison. Now remember, the range is how spread out the things are. The more spread out the values are, the less consistent they are. After that, we've talked about consistency in the test, and that is our context. So far what we've looked at here, we know what the values are we have to plot. We looked in the previous part at how you find these values. Now we know that we can also compare box plots. Now you're going to have to do some both drawing and comparing to practice this. But I'm going to go through one example of drawing with you. So, let's have a look. Here's a set of data which we're going to draw a box plot for. Okay, first thoughts. No outliers, that's good. If you want to have a go at drawing this box plot without me, pause the video now. Okay, so because it goes from 0 to 30, I'm going to use 10 centimetres for my scale. Now I'm going to put marks every centimetre. 10, and that's 30, so each mark is going to be 3. You don't have to write every number down, but you can. So, what's the lowest value? That's 3. What's the highest value? That's 28. What about the median? $16. 1, 2, 3, 4, 5, 6. The 6th bit of data. So, what's the lower quartile? It's the 3rd. And the upper is the 9th. So, there it is. 11. And there it is. 25. And there is my box plot. Now, the task you're going to have to look at as an extension is skew. Here are 3 box plots. Now, skew is when a few values shift the data, and it can be positive or negative. A positive skew pulls the data upwards, and a negative skew pulls the data downwards. So, let's look at the first one. We can see here lovely even gaps. There is no skew. What about the second one? Half your data lies here between your interquartile range. The final quartile there is quite narrow, and the lowest section is really big, as if it's been pulled down this way. Pulled down is a negative skew. On the next diagram, you'll see that actually not only is the interquartile range narrow, but there's another quartile that's narrow with it. So 3/4 of the data is in this tiny section on the end. And then the other quarter is dragged all the way out to here. And that is positive skew. It might help you, and it might seem obvious, that the 2 most recent things we've learned are linked. Here's a cumulative frequency curve. Here's the lowest value, and here's the highest value. Here might be the median. The upper quartile. And the lower quartile, making the box plot underneath. Now, let's recap. Box plots have 5 values on them. They're a good way of comparing things, and you should always talk about the median and the interquartile range. When you do that, remember to do it in context, so describe the actual situation, so that you can earn both marks. Practice drawing your own, and then look at skew and how cumulative frequency curves link to box plots. Positive skew is where data pulls it up. Negative skew is where data pulls it down. So positive skew would be Richard Branson sat with your teachers, because he earns a lot more, so he'd skew it up. And your maths teacher sat with Richard Branson and his friends, he would be a negative skew because he earns less. I hope that's helpful. Time to practice.